My name is Richard Steinke, and I'm the inventor of the Recovering Air Pollution System. And this is a schematic of our design, and I'll run through this with you so that you completely understand what the technology is all about. First of all, you have the boiler where the coal is put in and burnt, and then the residue of that coal, which is fly ash, SO2, SO3, and NOx, goes into the gas stream. We have a moisture sensor which will tell you the amount of humidity that's in the air, in the ductwork, and from there it will tell me how much more humidity I need to inject. As you see here, we have a feeder system. It's a sorbent. The sorbent that we use to take care of SO2 is lime, and commonly known as quicklime. But that lime is very reactive to and very sensitive to just a little bit of humidity. Also, on the other side of this is another hopper or silo, and that holds ammonia sulfate in powder form, and that takes care of the NOx. So we inject both sorbents into the gas stream. As soon as it's injected, we then sense how much more moisture we need to put in. If the moisture content is 8%, then we add another 8 to 10% moisture content in order to inject into the gas stream, so that we can get as much of the gases solidified. So our technology is we take the gases and put them back into a solid. So we solidify all the gases. And we do this, we want to do this in the gas stream before you get to the baghouse, because it's a concentrated area where we can get more completion of the gases back into the solid. We also want to, there's a thing called stoichiometry. And so what we want to do is be able to have a stoichiometry of 1 to 1. That means 1 pound of gas to 1 pound of the sorbent. So by making sure that we cover that whole gas stream with our sorbent, we then can get within this ductwork, which is called residence time, we would have enough time to convert those gases into a solid. We have total control of the moisture content and the feeding of the sorbents through our programmable logic controller, which controls the moisture, the temperature, the gas composition, and so forth. So we have that there in order to control these feedings and to read the moisture sensor. So anyway, it then continues down and goes to the baghouse. So you have pulsating bags. In the pulsating bags, we coat the bags, the outside of the bags, with the fly ash along with the sorbents. So this is the final place where we can capture the rest of the particulates, and we can capture all the fly ash, and we want to be able to capture all the gases which are now solidified. Then it drops down here, and this is where all the waste will end up being. You should then have clean air going to the stack and out of the stack. What you want to do then is, in our technology, we only have one place to deposit the waste. In a wet scrubber system, you would have a baghouse or an electrostatic precipitator. You would have a wet scrubber system over here, and then you would have a pond where you would throw the materials into to dry out. But in ours, we have just one area. Now what we want to do is utilize the waste. We're not just interested in, having this waste stacked someplace. So with fly ash and with the lime, you would actually add the physical properties will go up when you have that lime in there, and by adding a little bit of cement, you can actually it can become the subsurface to asphalt highways. So you can utilize this in all developing countries which need roads anyway. This can be totally utilized all over the country, and you're not just storing the waste or dumping the waste in the water and rivers and lakes and so forth. So you're actually doing something with it and making a product. So that is our complete system. It's very cost effective and very efficient. We are 1/4 the cost of any other kind of air pollution system. And it's very simple and very feasible and very easy to maintain in comparison to anything else out there in the marketplace. And this has been tested over and over and over again for many years. I actually invented fluidized bed systems for mining companies and so forth. And we've done hundreds and hundreds of testing on this exact technology, and this is the finishing touches to it, in which what we're bringing to the marketplace today. Thank you.
We got it.
That was much better.
That was much better.
Yeah, I got everything in.